With example 4, we're going to do an analysis that involves changes to the variable costs. Consider a company with fixed costs of $60,000 per month, variable costs of $375 per unit, and a selling price of $425 per unit. An increase in delivery costs added $30 per unit to the variable costs of producing each unit. A, how is the break-even point affected with this increase in costs? And B, how is the net profit affected if sales remain at 6,000 units per month? First of all, let's take a look at part A. So we're trying to compare the break-even volume with the increase in our variable costs. Currently, we have fixed costs of $60,000 and variable costs are $375 per unit. So our variable costs are $375 per unit times the number of units. Our selling price is $425 per unit, so our sales are going to be $425 per unit times the number of units. That leaves us with a contribution margin or a gross profit of $425 minus $375 or $50 per unit times the number of units. Our current fixed costs are $60,000, so we have $60,000 in fixed costs, and at break even, our net profit is equal to 0. So what that tells us is that at break even, our contribution margin must equal the same value as our fixed costs of $60,000. Our contribution margin has to cover our fixed costs. So there's our equation. 50N is equal to $60,000. Solving that equation for N, we end up with N is equal to $60,000 divided by 50, or N is equal to a value of 1,200 units to break even in our current scenario. Under the new scenario, we're increasing the variable costs, and the variable costs are increasing by $30. So the variable costs are going to go up by $30 per unit. So our new variable costs are going to be $375 plus $30 per unit. So in other words, our new variable costs will equal $405 per unit times the number of units. Our selling price is going to stay the same. It's still going to be $425 per unit times the number of units. What this means is that our contribution margin will go down by $30 per unit. From $425 minus $405 will leave us with $20 per unit times the number of units. If our variable costs go up by $30 per unit, our gross profit is going to go down by $20 per unit. We still have to meet our fixed costs of $60,000, and we want to know the profit at break even, and at break even our profit is equal to $0, and so therefore we know that our contribution margin must equal our fixed costs at the break even point. So there's our equation right here. So to break even under the new scenario, we've got the equation 20N is equal to $60,000, or N is equal to $60,000 divided by 20. N is equal to 3,000 units. So what happens to our break even point? Well, it goes from 1,200 units per month to 3,000 units per month, 2.5 times more than the original value. So now we have to take a look at what happens when we have sales of 6,000 units per month. So in other words, N is equal to 6,000 units. And we're going to compare both scenarios. The current situation is that our selling price is $425 per unit and our variable costs are $375 per unit, leaving us with a gross profit margin or contribution margin of $50 per unit. At 6,000 units, you're looking at $425 times 6,000 units. And I'm going to subtract from that 375 times 6,000 units. And that's going to leave me with a gross profit of $50 per unit times 6,000 units, or a gross profit of $300,000. And from my gross profit, I'm going to subtract the fixed costs of $60,000. And so the net profit that is left is $240,000. So our current net profit is going to be $240,000 at sales of 6,000 units. Now, what happens to this profit if our variable costs go up by $30 per unit? Our new variable costs are going to be $405 per unit. So they will be $405 per unit times the 6,000 units. Our selling price are still going to be $425 per unit times 6,000 units, and our contribution margin naturally is going to go down to $20 per unit times 6,000 units. You see, when you increase your variable costs, what that means is that your gross profit is going to go down. An increase of $30 per unit in your variable cost will mean that your contribution margin will go down by an equivalent amount of $30 per unit. $20 times 6,000 units ends up being a value of $120,000 in your gross profit. You still have to face your fixed cost of $60,000, and now that means that your net profit is going to be equal to $60,000, the difference between the two. So what that means is that now you've gone from a profit of $240,000 to a profit of $60,000 simply with an increase in your variable cost of $30 per unit. Your profit has now been reduced to 25% of the previous profit. That's a large drop.